sound, and then we'll be checking our sound. We're just going to get rid of that there. Okay. So just going to check the sound at this point, and we'll see how we go. Yeah, okay, and right. Okay, so just check our sound's all going good, and then we'll be away. And we'll see how we go. Well, looks like we've got sound. Okay, and yep, I'm happy with that. Okay. All right. Okay, let's get going. So I'm starting a little bit later tonight. I was watching a series on TV on Netflix Q, and it was the final episode, and I just needed a few extra minutes just to get it done. So really enjoyed the show, and I thought, well, we can leave the maths a little bit, and so here we go. Now, Netflix Q, and it was I thought tonight that I would just have a little look at we can leave the maths a little bit expanding. So here we go. And factorizing. So let's just have a quick look at factors. Factors. Just have a little look at. So factors are numbers that can multiply together to make a number. Now, and some numbers only have themselves and one. So they're prime numbers. Numbers prime that can multiply together, and so to make a number, they start with 2 is the first prime. Some numbers 2 times 1 only have themselves 3 and 1, not 4, because we can have 4 times 1, 2 times 2, and then 5 numbers prime 7, and so and the next one's 11. They start with 13, 2, and so on. Prime numbers. 3. So other numbers can be written, as we say, they can be written as a product of the primes. So if we look at 4, and I always equals 1 times 4. So other numbers 2 times 2. As we say, so it can be written as a product of prime numbers, in this case 2 times 2. So if we look at 4. All right, so that's our factors, and if we take a number like 60, 60, right? So we can factorize any number, so we can say, right, that's 1 times 60. All right, so 2 times our factors, and if we take a number like 60, 3 times any number, so we can say, right, that's 6 times 3 times 20. Okay, so these are all factors of 60, and then we can go 4 times 15, 3 times 5 times 12, 3 times 20. 6 times 10. Okay. So these are all factors of 60. And then we can go... And 4 times 15. 7 eighths. 7 goes into 60. 7 eighths are 56. And 8 goes into 60. So not exactly. And 9... and so on. So these are all the different factors of 60. And we can write it as a product of primes, which is a different thing. We can say, right, if we take 60, we can say that's 2 times 30, and 9. And then we can say, well, that's 2 times 2 times 15, so we factorise 30, and then we can say, right, that's 2 times 2 times 3 times 5, and that's it as a product of its primes, which we use a little square notation there, and we say that's 15, 2, and then we can say squared, that's 2 times 3 times 5. And that's it as a product of its primes. Yes, just got a bit carried away there. A little square notation there, and we say that's okay. And 2, right. So pretty sort of reasonable there. Products of its primes. Any number can be written as a product of its prime, as we said up here. The prime numbers, of course, 1 times 2, 1 times 3, 1 times 5. They just have themselves in 1. So, yeah, the factors, or we can say here, like in the case of 60, that 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30 are all factors of 60. We could say 1 and 60 as well, but they're sort of given. Right, so that's all great. 2, 3, so 4, 5, 6, 10, 12, 15, that's 20, what we call factors of 60. Now, if we go into algebra, we could say 1 and we can say as well, like 2a. The factors are 2 times a. Factors are 2 and a. Sometimes we write things when we tend to look at factors. We can have a number, so these are possible factors. Factors of an algebraic expression could be 2. Sometimes they could be x and variations of that, or x plus 3. So these are factors. Now, in algebra, one of the things that we do sometimes is we factorize numbers, and we write it as the number as a product of its factors. And then sometimes, recurring theme, we do exactly the same, the opposite, we go back the other way. So first thing we're going to look at is in algebra, one of the things that we do sometimes is we factorize which numbers, is and we write 2 times x number as a product of its factors. You'll notice that there's a difference. We try to differentiate between the opposite. We go back the other times the function and x the value. Now another thing that we can do is we can go which is 2 times x plus 3, and we put that in a bracket. So what does that mean? And now another thing that we can do why is how, and what's the deal here? Well, what it means is it's, and we put that in a bracket. So 2 times x plus 2 times 3. So we can write that, or that's called expanding it. What's the deal? Well, 2x plus it's 2 times 3, which equals 2x plus 6. And so going that way, so we can write that, or that's called expanding. Well, 2x plus 2. It means to make it bigger, which equals to make it bigger. Expand it. Expand. And so going that way, number. And the opposite of that is like we can look at this 2x plus 6. Now we've just expanded it, but now it's going to try and factorize it. Now if you look at the 2 and the x, you can see you've got the opposite of that, 2 times x. And if you look at the 6, you've got 2 times 3. So what we've got here is a common factor. We've just a factor that's common to both of those expressions, which is 2. And we can put that outside the bracket. You can see you've got, and then we can leave it out. And if you look at the 6, you've got 2 times 3 plus 3. So what we've got here is a common factor, and that's called a factor that's common to both of those expressions, factorizing. And we can put that outside the bracket. You can see you've got, and then we can leave it out. But remember, it all relates to the numbers. Now, is that right? That's that's called. So we've got here factorizing, and we can put that outside the bracket. 2x plus 3. But remember, equals 2x plus 6. That's called. So we've got here. So let's just say 2x plus x equals 5. But remember, equals x equals 5. And so we would have 2. So 5 plus 3. And that would equal x equals 5. Yep. And so we would have 2 times 5 plus 6, and which equals, that would equal 16. 2 times 5, yep, plus 6, 16. And here, we remember we use brackets first, which equals exponents, division, 16, 2 times 5, and multiplication together from left to right, addition and subtraction together from left to right. Here, we remember we use. But, I mean, let's put a story about this. Let's say division. Well, you know, try to make a story about these to make it sense. Everything has a story. I have. Let's put a story about this. I have 5 red chickens and 3 white chickens. Well, and each of them lay 2 eggs a day. How many eggs do I get? So I've got 5 red and 3. I have 5 red chickens. 5 red and 3 white. And each of them lay. So I've got a total of 2 eggs, 8 chickens, and they each lay 2 eggs. That's 16. So you could see here, or so I mean that's the logical way of doing it, I think. But so you and it's you do the brackets first and then the multiplication. But that's sort of how I make sense of that story. I don't know what else. You can try and come up with other options, but I mean that's the logical way should be 16. So you got 3 plus 5 is 8. Yeah. So you got you do the brackets first. 2 times 8 equals. That's sort of how I make sense of that story. I don't know what 16. Else. Like that. You can try and come up with other options, but I mean that's the logical way of doing it. So you got there 2 times 8 equals 16. So you can see that this one's gone 2 times 8 to get 16. This one here's gone 2 times 5 plus 6. It's a little bit different, a little bit different. But same answer, so they're both right. Okay, so you can see that this one's gone 2 times 8. Let's have another example, maybe. So let's do some variations. A little bit different. What could possibly go wrong? So, but same let's say expand. Okay, so you can see that this one's gone 2 times 8. Let's have another example, maybe 2. So let's do some variations. X minus 3. Go wrong. So what does that mean? Well, again, let's say 2x expand. Okay, so minus 6. 2x minus 6. 2. Okay, so the minus goes there. What about if we have minus 3? What does that mean? Again, 2x x plus 2 minus 6. So now we get minus 3x because it's the sign comes with. What about if we have minus 6? Minus 3. We can have things back to front. We could have 3 minus 3x. 2 minus the sign comes 7. Oh, minus 6. No. It wasn't what I wanted. We can have things 7 minus x. So that'll give us 21. 21 minus 3x. Now the thing to remember with these little expressions, they're like little packets, I think. They're like little packets and they come together. So minus 3x comes there. The 21 there comes, but it has, if it's positive, the positive, now the thing to remember, you can assume a positive. If there's nothing there, it's positive. If there's a negative there, it's negative. And then you can rearrange it. And so that'll equal, if you wish, negative 3x there comes, but plus it has 21. Now you'll notice that I put the negative up the top there. That's what I try to do to differentiate between the sort of function of minus, the actual activity of subtracting something, and the sign. So they're sort of interchangeable. So you can have you can have the sort of 4 of minus plus the negative 3. So, they're sort of interchangeable.
Which equals 1.
So you can have...
And 4 minus... You can have 4 minus 3 equals
negative
1.
3.
They're sort of the same. Hopefully you all know that and 4 plus is plus, plus minus, negative plus, negative, a plus, if you have these signs in a row. So that signs the same, plus is plus, same signs, plus minus, negative plus, and different signs, negative, a plus, if you have these signs in a row, minus or negative. So yeah, same signs plus, different things, negative,
same signs.
It's the same for multiplication and division as well.
Different signs.
Yep, nice little rule that you probably expected to know. Same signs plus, different signs, negative.
Plus, different things,
Yep.
negative.
That's how we roll.
It's the same.
Right, so now it gets a little bit,
for multiplication.
let's get a little bit more
as well.
complex.
Yep.
And
that you probably expected to know.
there's many ways of working this out, but let's say we have x
negative
plus 2
negative. That's how we roll.
multiplied by x.
So now it gets a little bit.
Let's get a little bit more.
as well.
Plus 3.
And
How do we do that?
probably expected to know.
Well,
Many ways of working this out, but
Um,
let's say we have x
perhaps
plus
the
2
longest way of doing it, or the
multiplied by x.
you know, the longest way is you multiply
Plus 3.
x times that whole bracket.
How do
So
we do that?
x bracket
Well,
x plus 3,
we have x. Perhaps
right?
the
And then
longest way of doing it, or the
so you write down that, and then you write down the plus
longest
2
way is you multiply
x plus 3.
x times that whole bracket.
Okay,
X
and then you work them all out. So
plus 3.
there you get x, which is x squared,
And then
and plus 3x,
then you write down the plus 2
and then plus 2x, and then
Okay.
plus 6.
and then you work them all out.
And then we collect all the terms
There you
together,
get x, which
and we
is
get x
x
squared,
squared,
3x plus 5x, 3x plus 2x is 5x, and then plus 6.
plus 2x,
And that's it.
then plus 6.
That's it there,
Work them all out.
expanded.
Collect all the terms
So
together.
here we have it,
And we get
factors,
x squared, 3x plus 5x, 3x plus 2x is
Expanded.
5x, and then plus 6. 2x.
some would say this little operation here is simplifying.
Expanded. So here we have it, factors,
Simplifying.
3x,
Yeah.
5x, 3x plus 2x.
Okay, so let's have a look at that.
Some would say this little operation
So,
here is simplifying.
right, now we get into some, so that was, that one there was just, yeah, let's have it, that was
Okay,
x
so
plus 2, x plus
let's
3.
have a look at that.
There are other ways of doing this.
So, right. Now we get into some.
Let's,
So that
undo
was,
that.
that one there was just.
And,
that
was,
Okay.
X
so
plus redo that. Oh, no.
3.
Um,
There are other ways of doing this. So,
Come on.
Now we get into some.
Undo that. Right. X and plus. Oh no.
That was
Redo that. Oh no. We want it in black. X plus 2. Oh no. Still no. Come on. Right. X plus. Oh no. Redo that. Oh no. We want it in black. X plus 2. X plus 2. Still no. Come on. X plus 3. Now there are a number of ways of doing this, and they have different mnemonics and things like that. So if you have a way that works, that's good. You don't have to do it my way. Typically this is my way. I go like 3. That
there are a
one times
number
there.
of ways of doing this, and they have
That one
different
times
mnemonics
there.
and things like that. So if you
That
have a
one
way that
times
works,
there.
that's good.
And
You
that
don't have
one
to do it
times
my
there.
way. Typically this is my
Okay.
way. I
And
go like 3.
some say it looks like a kiwi. So you can go like that. First one. So that's 1, that one times there. 2, 3, and that 4 times there. And then some say that's the first. And that's the outer.
like a kiwi.
This
So
is
you
the
can
inner.
go like that.
And this is the last.
First one.
So that's the foil method. FOIL.
3.
First, outer, inner,
Some
last.
say that's the
Foil.
first.
This little shape, some would argue, looks like a kiwi. I think we have to draw this back here.
The last.
So that's the looks like a bit of a kiwi. There. Now, how do we do it? So,
Outer, inner,
in this
last.
case, the first one here is x squared.
This little shape, some would argue, looks like a kiwi.
Second one is plus 3x.
Looks like a bit of a kiwi.
So that's the outer. The inner,
There. Now, how do we do
plus
it?
2x.
So,
And the last
one here is
6.
x squared.
And then we collect all the terms together.
Second one is
Oh
plus
dear.
3x.
So that's the outer.
The inner.
Collect all the terms together. And we should get x squared plus 3x plus 2x plus 6. Collect the terms. X squared plus 5x
We should
plus
get
6.
x squared.
Okay, so that's yeah, that's one there. So yeah, there's lots of different things that can happen here. So for homework, what I'd like to do is to look at these ones here. X plus 2.
Yeah.
X plus 3,
So yeah,
which we've already done.
there's lots of different things that can happen here.
Both plus, and
So
then we're going to
for
go
homework,
x
what I'd like to
minus
do is to
2,
look at these ones here.
x plus
2.
3.
Yeah.
So negative plus,
X plus.
and then we're going to go
So yeah,
x
which we've already done. Lots of different things that can happen here.
plus 2,
And then we're going to go x minus
x
2.
minus 3,
These ones here.
and then finally we're going to go x so minus
Negative
2,
plus. And then we're going to go
x minus 3.
x So what I've done there is that looks at all of the variations possible with those two factors. And then finally, it's got plus and minus 2, plus and minus, well, plus 2 with plus 3, minus 2 with plus 3, plus 2 with minus 3, minus 2 with minus 3. Signs the same and positive, signs different, it's got plus and minus 2, signs different, signs the same but negative. Plus 2 with plus 3. So we'll do those ones over the for tomorrow. And yeah, we'll just leave it there. So yeah, thank you so much for joining me. And we'll have episode 17 tomorrow. This has been a Maurieo presentation, recorded live in our lovely little studio in downtown Naruawa here. The Big Smoke in Aotearoa, New Zealand, the place where Kiwis live, in a paradise we like to call God's own country. Good night, and good gardening to you all. Recorded live in our lovely little studio in